Each atom contains neutrons, which is neutral, and protons, which are positively charged. The proton number in an element depends on an element's physical property. There is no two elements with the same number of protons. The electrons, which are negatively charged particles, orbit around the nucleus. Electrons and protons attract each other, therefore, atom has the same number of protons and electrons. For example, helium's atomic number is 2. Taking the sum of the number of protons and neutrons, we can get the atomic mass unit, which is 4. In the topic Bohr's model of atoms, Niels Bohr in 1915 said that electrons revolve around the nucleus in specific orbits, and these orbits are associated with definite energy, which are energy levels or shells. The formula of maximum number of electrons in each shell is 2n squared. Using the periodic table, he also proposed that the number of electrons that can be filled in the outermost level is 8. The orbit that is the nearest to the nucleus has the least energy, while the orbit that is furthest has the maximum energy. When an atom absorbs energy, the electrons get excited and jump to the higher energy level. The electron will also lose energy and drop down to the lower energy level. Conductor is the material that easily conducts electrical current. A material is a conductor when one or more valence electrons can be easily freed. Most good conductors have one free electron in their valence shell, and they do not require much force or voltage to free their electron and allow current flow. Insulator resists electron flow and takes much more force or voltage than conductor to free their electron because their valence electrons are tightly bound to the atom. Plastic, glass, and rubber are commonly used as insulators. Semiconductors are neither good conductor nor good insulator. They can be made partly conductive by mixing small amounts of impurities containing free electrons, such as silicon and germanium. Next is the difference between the energy gap, conduction, and valence band. Energy gap is the difference in energy between the valence band and conduction band. Valence band is another name for an orbit shell, while conduction band is the band outside valence shell when it has free electrons. This energy band diagram shows that the energy gap of insulator is the largest. For conductor, both bands are overlapped. For semiconductor, there is a small energy gap between two bands. The spacing of the energy level and how they are filled with electrons that jump from lower level to higher ones will determine the material is conductor, insulator, or semiconductor. If there is a huge gap between the lower energy level and highest one, it is hard for electrons to jump to higher level, so current cannot flow. Insulator like glass has very small conductivity. Metal has no gap at all. Electrons can move to the higher energy level with no problems, hence current can flow. Semiconductor for somewhere in the middle, it has a medium-sized band gap. So technically we can make a semiconductor conduct electricity if we added enough energy through heat to push the electron into a higher band. For semiconductor, the band gap is small enough that the electron can jump into the higher level band for current flow. The amount of heat we apply determines how many electrons jump to the higher band and how much current flow.
N-type semiconductors. When a small amount of pentavalent impurity, such as arsenic, is added to a pure germanium semiconductor crystal, the resulting crystal is called N-type semiconductor. The diagram shows the crystal structure obtained when the pentavalent arsenic impurity is added to intrinsic germanium. The 4 valence electrons of arsenic atom form covalent bond with electrons of neighboring germanium atoms. The 5th electron of arsenic atom is loosely bonded. This electron can move around almost as an electron in conductor, and hence it could be the current. P-type semiconductor. When a small amount of trivalent impurity, such as indium, boron, or gallium, is added to a pure semiconductor crystal, the resulting semiconductor crystal is called P-type semiconductor. The diagram shows the crystal structure obtained when trivalent boron impurity is added to the pure germanium crystal. The trisvalent electrons of the boron atom form covalent bond with the valence electrons of 3 neighboring germanium atoms. In the fourth covalent bond, only one valence electron is available from germanium atom, and there is deficiency of one electron, which is called as a hole. Hence, for each boron atom added, one hole is created. Since the hole can accept electrons from neighborhood, the impurity is called acceptor. The hole may be filled by the electron from the neighboring atom, creating a hole in that position. From there, the electron moves. This process continues, and the hole moves around in the random due to thermal effects. Since the hole associated with the positive charge moving from one position to another, this is called as P-type semiconductor.
Conduction in semiconductor. The model shows the structure of crystal lattice in silicon. Silicon which has 4 valence electrons in outermost shell. At absolutely 0 Kelvin, the electron is strongly bonded to parent nucleus. However, when heat supplied, the thermal energy may be greater than the bonding energy. Therefore, the bond breaks. The electron absorbs energy and moves from valence band to conduction band, leaving a net positive charge which is known as hole. Since the atom has a net of positive charge, electron neighboring may attract to it, so that the hole seems to be moved to neighboring atom. The electron at its matching valence band hole called electron-hole pair. After the electrons excited to conduction band, they will lose energy and stabilize back to valence band, recombining with holes. This process is known as recombination. This recombination process happens continuously. When electric field is applied, the electrons no longer move randomly. The electrons are urged to fill the holes. The holes move in the direction of current, while the electrons move in the opposite direction. The movement of electrons is one type of current in semiconductor called electric current.
The cold are both so intense, put them together, it just makes sense. Winter's a good time to stay in and cuddle, but put me in summer and I'll be a